I'm Chris Taylor. I'm Associate VP for Research in University of Manchester, but in HeRC I'm one of the investigators and I'm a member of the advisory panel. And I think that's all you'll hear from me. I shall just manage questions and answers. So as Iain said, we've got theme leads sat at the front here, and they've all been asked to give a very brief introduction to their theme, to leave time then for questions and comments from all of you. And I think the idea is probably, since we had to cut off questions for the earlier speakers, we can take questions from them as well in this session. Well, are you going to speak again, Iain, on your theme? I should have asked you that. Fine. So, well, let's kick off at that end and ask Iain to speak. And sorry, I didn't make introductions to save time. If people can introduce themselves as we go.
So today I'm being Will Dixon and Sean Lewis. They unfortunately couldn't be here, so I want to give their linked perspective on co-producing observation with patients. We have a lot of innovation in different areas of patients and clinicians co-producing observation around this region. For example, facilitated access to primary care records and how that changes the conversation between patients and general practitioners. Patient-reported outcome measures used as a triage mechanism to avoid unnecessary follow-up visits, post-surgery, and more patient involvement in measuring symptoms. Examples I showed in my talk of smartphone applications designed from theory and tested in a proper psychometric framework to try and reduce relapse rates in schizophrenia. One of the funders of the HeRC is Arthritis Research UK, and they are embarking on an ambitious linked data initiative to bring together a large case cohort. So routinely, as part of rheumatological practice, there will be core data sets laid down with usual but structured clinical measurement and a conversation between clinicians over that. Rheumatology is an interesting example of where there's a lot of trial and error within individual treatment. For example, the timing and the dosing of steroid treatment. Now, many of those small transient effects will not be captured by one code in a primary care or secondary care record of how Mrs. Jones got on with her steroids. But maybe we can get new signals from being part of people's daily lives and having a regular measurement that will produce new insights with much richer longitudinal data. So HeRC has set out to create a crosstalk between that work that's been developing an evidence base about the cognitive models for interacting with people on their symptom experience in their daily lives from adult psychiatry, through to rheumatology, where there's a big need to disambiguate some of the conflicting evidence about drug outcomes. Thank you.
Okay, I'm going to stand up. Being so small, I don't think those at the back can actually see me. I'm the Biohealth Informatics Education Development Fellow here at the University of Manchester, and I'm going to be leading the education theme. And I thought I'd just give you a snapshot of what our objectives are over the next 5 years and what we will deliver through the centre. So previously, we've really heard about bringing together the data, the methods, the experts to link between what we do in research and how we deliver that service. Well, we have a bottleneck. So we have all this data, and it's getting wider and wider and wider, but our ability to analyse that data is actually seriously constrained. We all know that there's loads of information in that data, and the intelligence from that can then be used to improve that delivery of healthcare. And yet, where are the skilled researchers who are familiar with working in that type of environment? In 2010, I think MRC came and did a survey of what skills were available and what were the shortage of skills. We all come from this diverse background. NHS, academia, industry. We all have a unique role to play in understanding that data with all different methods. So for the NHS currently, they're having a shift from perhaps the information technology that they're going to use to more what are the business intelligence skills that are required to understand and improve delivery of healthcare. In industry, they're interested perhaps in how drugs interact with individuals in that endeavour for personalised medicine. We all come from computer science, epidemiologists, a wide range of backgrounds, and yet I've just hinted at we've not got the right skills. Well, actually, we have, okay? We're all experts in our own disciplines, but we need to be able to translate our expertise into an arena that allows us to work in this e-health research environment. So that's what HeRC is going to do. It's going to provide this learning platform that will allow us to translate our skills and to be able to innovate in the e-health arena. There are certain things that we will achieve. We're going to put on continued professional development courses that will help people translate and work in this environment so that they understand the clinical, the management, the social, the ethical issues when looking at this type of data. We're going to have a very strong career development plan for what it is to be an informatician. It is widely perceived at the moment that informatics is a support role, but it isn't. We're now at the forefront. We're taking centre stage at being able to deliver that improvement of healthcare. So we're going to set up a doctoral training network across those partner institutions so that we can train the next breed of researchers, the next leaders in e-health to work and to innovate in this area. We're also hoping to tackle or promote health informatics in medical training. There's been a shift that clinicians are now being involved in engaging in informatics platforms, what they should look like, how they should look. Well, we're hoping to promote the awareness of health informatics through introducing a curriculum into medical training. This can be small step through informal awareness programs, or hopefully perhaps introducing it in an intercalated degree at undergraduate level. We're already making moves of introducing clinical fellowships in health informatics. And finally, learning open resource. Can we train the general people and open learn and open our resource of training materials so that people can have a grounding in the area? And I think this will start to stimulate the activity and what it is to be a health informatician. So finally, HeRC is going to be this research-led education ecosystem. I think it's going to be built for us, by us. We all have the expertise, and it's about working together and sharing best practice and being able to use our skills in this arena.
Thanks, George. That was Georgina Moulton. I don't think you introduced yourself. And I think I'm now passing you on to an imposter.
So I'll stand up as well. You started the trend, Georgina. I'm Ben Brown, and I'm going to be Ben Bridgewater for today. So same first name, same letter for the last name, but different in other aspects, in that I'm not a cardiac surgeon. I'm a trainee GP, so I'm a GP registrar, but I spend half of my time funded by the NIHR to do academic research training, and I've just started, or about to start, a PhD on the missed opportunities detector theme. So I'm going to give you an overview of that theme today. And I suppose if you to put it as put it in a nutshell, the missed opportunities detector is working out ways to do things better based on how we already know how to do them, basically. So the example that we're tending to use at the moment is that for For every heart attack that happens or any other cardiovascular disease event, we know how best to treat those risk factors that lead up to it. So there's plenty of guidelines out there, plenty of clinical pathways. So what's happened along that pathway that could have been done differently, that could have prevented that adverse outcome from happening? And the way to conceptualize it is to have two ends of a spectrum, really. At one end, you have the clinical guidelines, the care pathways that tell us the supposed best evidence and best ways to treat patients. And then at the other end, we have what actually happens in real-life clinical practice, and that's captured in the healthcare record. And various factors interact in terms of the fidelity of that information at either end. Some of those are patient factors, some of those are clinician factors, some of those are system factors. And in the middle, in terms of the mismatch between those two, are missed opportunities. And that's what we're going to be looking at, and that's what we have looked at so far. So in terms of the objectives for the Missed Opportunities Detector theme, I think there's three main objectives, and the first one is to develop a health informatics methodology and tool for detecting missed opportunities. The second one is to use that tool to extract useful and implementable clinical information to improve the health system and outcomes for patients. And then thirdly, to develop interventions to improve the health service and evaluate those tools that we do develop. The advantages of taking this approach are numerous, and I'll just go through some of them now. I mean, if this is done in a cost-effective, automated and timely way, then this is very useful information for on the individual patient level to improve care. As a clinician, I would find it very useful for the patient sitting in front of me of how I can best do things better for them. But also at the population level in terms of improving the health service for if I was a policymaker or a GP in a clinical commissioning group as well. We're using real-life patient data, which has advantages over clinical trials. We've got data on elderly patients and those with multiple comorbidities who are traditionally excluded from clinical trials. So we're getting real-life usable information as well. And I mean, over and above the use of audit, we're looking at cross-cutting pathways that go across different settings, whereas traditional clinical audit will just look at specific disease areas in specific settings. So what we've done so far, from my point of view, the work we've done on missed opportunities, is we've started to look at cardiovascular disease and the adverse outcomes from there, so stroke, TIA, heart attacks. And so far we've looked at blood pressure control. And we found some really interesting information there. We've applied health standards from National Institute for Health and Clinical Excellence, NICE, and CoOP. And we know that from some of the information that we've gleaned so far that patients who are older, those with more than one comorbidity, tend to have uncontrolled blood pressure. So that raises the questions of, should we be targeting these populations more to prevent these outcomes? But it also raises other questions as well, such as, well, are these missed opportunities that we've identified, are they clinically significant? Why are they happening in the first place? So there's further work to be done on qualitative analysis of the electronic health records, perhaps using text mining or other ways of interrogating the health record. And we've also found very interesting results in terms of the actual targets used within the guidelines as well. So, you know, are the guidelines telling us the best way to do things as well? So, found some interesting information, but lots more questions to be answered. And I'm really looking forward to developing it further, so thank you.
Thanks. Hi, I'm Adnan. I'm going to be myself. I am head of the Respiratory and Allergy Center in the Institute of Inflammation and Repair, and I lead SAE3. And here, the challenge is stratified medicine. And we're great, we all pay lip service to stratified medicine, and then really what we practice is one size fits all. And we use asthma here as an example, but it's really transferable to many other diseases. I mean, Salford lung study is a beautiful example of one size fits all approach. Every asthmatic in Salford is going to get the new drug. And the new drug is really exciting. It's a glorified extract of adrenal gland, inhaled corticosteroid and beta-2 agonist. We are, in 21st century, exactly where we were in 1960s. It is very interesting. Industry is waking up to the fact that their pipelines are completely dry. They produce fantastic drug using the model that has run out its course. So what is endotype? And I'm going to use a good example of fever. And if you pick up 19th century textbook, fever was a disease. It was a great disease. That is a phenotype. Then we understood that fever can be caused by bacterial infection, viral infection, and a number of other causes. Those are endotypes. And when you try to treat fever today, you will treat it depending on what the cause of that symptom is. That is endotype-driven treatment. Now in asthma and in many other complex chronic diseases, we use these umbrella terms. What we want to make sure is that as a result of what we're trying to do, the term asthma disappears from textbooks in 20 years' time, because this is umbrella term. This is a complex phenotype that arises through a number of completely different pathophysiological mechanisms who end up giving you very similar clinical presentation. In order to really practice stratified medicine, you need to understand those different endotypes, those different pathophysiological mechanisms. This is the first step to novel target discovery. This is the first step to giving industry an idea of where to look next. How to do this? It is a big challenge, and for us, Iain has talked about challenges of messy data in healthcare. What we are faced with is a very different challenge. In the UK, we are definitely the world leaders in birth cohorts. We have 5 great, mature birth cohorts looking into the development of asthma and allergies, from Elspeth in Bristol through Manchester, Aberdeen in Scotland, Isle of Wight and Kent. More than 18,000 children with extremely rich data sets. Very different levels, from molecular level, from genome-wide association studies up to very complex phenotypes. Now, how do you integrate these data? How do you integrate these data to understand the disease, to discover endotypes, as a first step to discovery of pathophysiological mechanisms and new target discovery? That's the big challenge. We're using asthma because we think it's a good example, but you can use it for a number of other diseases, from diabetes, arthritis, any common complex disease that has arisen as, from complex interactions between genes and environment will be the next target. We think asthma is probably the easiest one given the infrastructure that we have. And the infrastructure that we're going to use is the MRC-funded consortium of UK birth cohorts, STELLA consortium, which we coordinate from here in Manchester, and with help from Iain's team and John Ainsworth, we're going to create Asthma eLab to really finally bring all of this data together as metadata and making it usable. Once these basic building blocks are in place, we then plan to utilize novel, innovative techniques for analysis of data that will enable us to look at very different levels of data, as I said, from molecular level to population level. And then, that's the first step, of course. Then there are great other examples like Born in Bradford cohort, which has all the healthcare utilization data. There's Salford lung studies, where we will be able to test all the hypotheses that arise. The day of hypothesis-driven research in asthma is probably over. we need to generate hypotheses. And this program is about hypothesis generation. And thankfully, Claire Mills, who very recently joined us, brings with her another great data set. More than 20,000 children really meticulously followed across Europe in Europe-Preval birth cohorts, which we also coordinate, and where another allergy e-lab will be housed in Manchester. So the challenge that we have is to utilize all of the data that we have, and we're confident that through this we will discover novel endotypes, and hopefully it may give us an idea of where to look, target identification, new molecule discovery, with the ultimate endgame of endotype-specific treatment, stratified medicine. I want to retire with asthma cured.
Hello, my name is Goran. I'm from School of Computer Science, and I would represent more techie guys in HeRC. So I've got a first challenge is actually to tell you what is the name or the acronym actually that stands for our work package. Is called CheapSet, and I would like to offer a free coffee for anyone who can remember what it is for. So it is Community Health Intelligence Partnership Semantic Epidemiology Toolkit. So, but basically, a simple thing is actually to help all other guys actually answer their research questions. So if you look at the figure that describes what the HeRC is about, we are the only horizontal theme package or theme that actually tries to support all the other research areas. So the idea is actually to provide kind of underlying infrastructure that can support all the data management that other people were discussing and asking questions about. I'll come back to that in a moment, but basically the idea is that we try to provide a methodology toolkit that can help people do their job by integrating all the data that is available around. The idea is that toolkit that is provided is going to be shared, is going to be reusable, is going to be extendable, so applicable in all the different themes that we have, but also secure. IT governance stuff is something that we have to take seriously about, and we will do that so that the data is anonymized, the data is secure, that it can be shared between different data providers. The approach that we will follow is based on a big health data. So we've heard that Northwest has around 5 million people. So Manchester only have the Manchester Central Hospital have more than 1 million appointments a year. So across the Northwest, you can imagine how many appointments we've got. So we need somehow to integrate this data, and our approach is based on semantics. Many people have mentioned linked data. Linked data has two interpretations. One, what we actually mean by that is just linking the data, but there is a technological aspect of it as well. And when we say we're going to link linked data, we're going to do it in a way so that semantics and metadata from different sources is maintained. I've tried to put together probably 3 aims that this theme will try to deliver. The first one is to harness all this data that is available around, so to establish and recognize what the best practices are, and then to share it across different themes. It will include 3 things. So first one is capturing the data as it is, so from electronic health records, then from EPROMs, so patient-generated outcome measures, from mHealth and wherever else the data might come from. For example, it might also come from social networks where patients actually describe what they feel. That's the first step. The second step is then to mine and link this data, so extracting data from electronic health records, linking that to other databases, linking across the databases, and there are technologies to do that. And the final thing is about analysis and putting this data in a system that can support decision support and research. This type of analysis is going to be based on methods. So the work that has been done previously with Carol and Iain and other people, they are based on method box and e-labs. So e-labs have been mentioned a lot. So we plan to use this as a kind of best practice and framework to offer people do their analysis. Moreover, what we plan to do, and that's one of really big ideas here, is actually to use machine learning and biostatistics on linked data to help bring together all these data sets together and provide some new patterns and some new insights. One of the applications is obviously semantic epidemiology, but we just consider it as a recurring theme across all the different themes. The final thing, the third aim that we would like to deliver is that technological aspects of these projects are not only service software engineering. There is a lot of science, a lot of research that is hidden in the requirements, I would say, from different themes. So there is a lot for us to think about how to solve these problems. If these problems were solved, then you would probably have commercial products already ready for you that will come to NHS and say, okay, here is the package, you use it. So there are many problems that need to be really solved. So we'll try to make this all about real stuff. So we'll try to have real world, well, you do have real world problems, we have real world data, we have real time procedures to make the analysis and integration of this data. And finally, I just want to say this is across the consortium work package in the sense that we have expertise from Manchester, also from York and from Lancaster and Liverpool. So it's going to be a pool of methodological expertise that will be offered to all the themes to use. Thank you.
Hello, my name's Arima Ochi. I'm a Wellcome Trust Engagement Fellow at the University of Manchester, and I'm on the strategic team for the patient and public involvement work stream, and I'm representing Mary Tully today, who is one of the theme leads. I wanted for a moment to put ourselves in the shoes of the public. We are the public. We've all been patients. I challenge that anyone here has never stepped into a doctor's surgery, never been in a hospital. No. Okay, so let's put ourselves for a minute into that perspective, the patient perspective. And what might you imagine as patients, what are your concerns with this idea of opening up your data to us to do things with it? Who would you trust who would you put that data in the hands of to develop applications of using that data? I just wanted to think about a few ideas, if anyone had any thoughts on that or any questions about the ethics of it. So what might your concerns be?
Exploitation by commercial organisations.
Yep, so exploitation by commercial others. Big Brother. Anyone else? Insurance premiums. Okay, so that's just from 3 people in the audience, and we might imagine that the public will have these concerns as well. So really, PPI workstream is about presenting that opportunity where we can have that open, honest discussion with the public, and that opportunity to and the public's concerns to inform the work of HeRC. So there'll be a public PPI forum set up, and also a strategic team, which will include people from that PPI forum. And there'll also be, and I think this is perhaps quite the most exciting bit of it, and that is looking at new methods in which the public and patients can be involved in the co-design of research. So this will be happening and be embedded across all of the projects, but what are some of the new ways in which this might happen? And one of the things that, in my role as an engagement fellow at the University of Manchester, one of the things that I used to do was to get involved in citizen-led innovation at Lancaster University. So working on a project that was looking at how technology might support social change. So working with, for example, people that lie outside of the mainstream. So working with homeless people, working with people on the autism spectrum disorder, and finding it being very challenging, actually, to be able to co-design applications or technologies that might support these kinds of people. And from that, of course, there were academic benefits, but also social benefits. And I'll leave you with a story. There was an Italian guy, Salvatore, I can't pronounce his surname, Iaconesi, I think, and he is an artist. And he walked into his doctor's one day and he'd had the results back of a brain scan, and he was given the news that he had a brain tumour. And being an artist, he wanted to respond to this news in a way that gave him back the power of not just being a patient and this dialogue that he had with his doctor that was kind of, it's bad news. And what he did was he hacked his medical records and he put them online. And he put them out there and got maybe 1 million responses from people around the world, some from surgeons who were offering him other treatment options, but many from members of the public and other artists who took his data. One artist took the data from his scans and made a sculpture of his brain tumour and sent that to him. So if there's this kind of creative and exciting response that might come from an artist who wants to do something and have changed the dynamic of relationship with his doctor, there'll be a number of different ways in which we can draw on these insights, creativity and inspiration that come obviously from our side of the fence, but also from the public side of the fence. So what I'm really excited about when we think about PPI is this interface, this edge between public and academia and the social innovations that might spring out of that. So part of that is thinking about the social life of the data. What might the public like to do if that data is opened up? And that presents opportunities to do kind of hack days, data visualizations that will enable us to see other patterns in the data. Oh, I should say there's an opportunity to get involved in it. There's a job going for PPI manager.
Okay, thanks everyone. Thanks for keeping to time. I'd better stand up so I can see if people put their hands up. So we're open to questions, comments. And remember, that can be to the people who spoke earlier, or it can be to the panel sat in front of you.
I've got 2 questions, but I'll just ask the one now. Perhaps I can have a second cherry bite later.
So, sorry, I should say microphones will come. So.
Okay, so here's the first of the 2 questions. It's to Iain, really. Your very first comment was that the HeRC here based in Manchester was one of 5. There were 4 others around the country. And I think you used the word network to describe the relationship between those others, between the various centres. So my question is, to what extent, we haven't heard you describe, or hadn't heard anybody describe, what the network efficiencies are that you envisage might come from the existence of this network. In what ways are there to be divisions of labour? What are the current divisions of labour? What are the different focuses of the different centres?
Thanks, Martin. It's a good question. There are 4 centres, and I put up their common mission, which is harnessing UK health data for patient and public benefit. Scale was the very last word on my last slide. One of our themes, which we haven't had time to discuss in detail, is the diabesity outcomes translator. The word there is translate to a larger scale. So if I'm looking at the cancer risk of diabetes treatments, so increased risk from long-acting insulins, decreased risk from metformin, lots of confounding factors, confounding by indication, complex time-varying exposures, lots of ways to be uncertain. Difficulty in exploiting heterogeneity, so the different prescribing environments, the different disease risk environments, the different time courses that we're looking at, cohort effects, period effects. If we're to do that at scale, we need those centres to work together to a common mission. Box number 1 signed up to a common mission, but it's more concrete than that. There are current plans, there's a lot of conversation between the directors of the centres and the people building the technical architecture to take those kind of examples and ask, how can we increase both the sample size and that useful heterogeneity to give us a combined statistical model that is likely to be a more informative model. And how can we do that in a way that arrives at the intermediate results that are shared much sooner than your usual investigate and publish cycle?
Other questions, comments? One over there. I think the microphone's coming.
If it can go wrong, it will go wrong, is a premise. The more you mine data, the more in principle you've got the chance of a recurrence of what's happening in Swansea at the moment. I haven't heard anything today which says what's going to be put in place to protect that sort of an outcome of research.
Okay. Would you like to have a go at that? Can I?
That's very, very important question. Very important question. However, this is part of our responsibility, isn't it? The other one is, the reality is when you look at medicine today, people say, oh, it's so complex. So it's very difficult and we can't manage it. What I would say is, let's embrace the complexity. The complexity is really beautiful. Biology is beautiful and we can understand it. I think what is built into each of the themes is a very rigorous sanity check. And very rigorous sanity check is making sure that any signal is confirmed and replicated until the moment arises where your confidence in the finding is such that you do not go and publish on 12 kids. It is about sanity checks which are really part of the whole process. And that's, I'm absolutely certain, what this HeRC is gonna deliver.
Iain, do you want to add to that?
We often describe it as a social network of sense-making. So one of the ways that we'll get those sanity checks is to share emerging findings with a bigger group sooner. And that is quite an engineering challenge.
Okay. A couple down here.
Thanks, Gareth Evans. In view of the last speakers sort of bringing the patient perspective into this and, you know, how patients are going to feel about this, what is HeRC going to put in place? How is it going to address the issue of connectivity of data which may eventually have identifiable natures to it? I imagine, you know, NHS numbers is the obvious way of pseudo-anonymizing all of this and collecting data from various sources, but someone's got a connector for an NHS number to a date of birth and a name, and sort of what's going to be put in place to make sure that there isn't a USB dropped somewhere with that sort of identifiable data on that can be sold on, as we heard, to insurance companies, et cetera, et cetera. Just wondered if that could be addressed.
It's a good question, Gareth. We have a three-pronged approach here. Number one is to reinforce good information governance. So most of the examples of things going wrong are through human error, not following a standard operating procedure. They're not through a technical difficulty most of the time. So good, solid management creates safe havens in which you can do deep research where there may be a potential disclosure risk, acknowledging that there is a risk of underexploitation of data as well as overexploitation of data. I mentioned at the end of my talk that I'm kicking myself about not knowing some evidence that could have been useful to a member of my family on the use of N-acetylcysteine. I know that best guess uses of that are happening all over the country today. And if we get the information governance right, with benefits and risks balanced, maybe I will be sitting here in 10 years' time and be able to log on and see all the people touching records around research that might answer the question my family couldn't use in time. But I have a strong public interest in knowing that that question is being followed right now. So Goran alluded to the engineering being cross-cutting, to build in the ability that comes from the science, the computer scientists being plugged into next generation web, which is being engineered to know, to give you the heads up on who's touching your data. To bring that sort of thinking through to making the uses of the data much more palpable, much more interactive with the public, and at the same time, I think that can improve our management of good, solid information governance.
And there was one just there. Sorry, I'm sorry.
So I guess there are two technical ways that can help actually ensure good IT governance. One is there are algorithms that can help you calculate the risk of disclosing information, and in particular in the linked work, linking it to other data sets, because the problem is not really distributing one data set. It is actually a problem when you try to link it from different sources. And there are algorithms that can help actually establish the risk and estimate that risk. So that's one thing. The other thing is, for most of the research, you might need aggregated data. So data that doesn't necessarily tells you all the details about a particular patient, but you just group the data, aggregate data, and then you use that for the research.
Peter wanted to make a comment too.
Yeah, just a very quick follow-up, but it slightly overlaps. I do think, in my experience, current NHS ethics concern about potential disclosure of sensitive information, there's a slight risk that they confuse two things. One is the legitimate concern that sensitive information is inappropriately disclosed, and as a result of that, far too often, well-managed research projects are prevented from accessing the data that allows them to help the public. And you know, if we can convince ethics committees that we can be careful custodians of data, we can actually do sharper research.
Helen Wilding from New Economy, and we're an economic development agency covering the whole of Greater Manchester. A few people have talked about the potential commercial value and commercial opportunity arising from all this work, and you can definitely see how there is potentially huge value there. I was just wondering if the panel had any views on how that value and that opportunity can and should be best exploited, bearing in mind this primary aim of patient and public benefit and the importance of not compromising that, which previous questions have alluded to, but also secondly, ensuring that any economic benefit that does come from this work can be felt and captured in Greater Manchester, but the wider northwest and north of England as well.
I think, Iain, that's probably one for you.
So science parks and incubators are set up for public benefit, and I see this as a virtual science park and an incubator of best methodology for doing that hard harnessing of data methods and expertise. We're committed to doing it in the open, so we'll publish our methods, we'll use open standards, we'll borrow strength from others who've built something before. We won't just build it for the sake of building it. We will educate about those best practices, the relevant platforms and tools, and we will open source the extensions we make to those platforms and tools ourselves. And if we can do that within a social contract, our populations in the north are particularly participative. We've had great examples, for example, the Born in Bradford study, initiated by the local community for many different reasons. Linked data exploited for different motivations, but there's a civic pride in that. If we can have a similar civic pride in the kind of incubator that leads to better exploitation of health data for both public health gain and developing our industries around the data, being very transparent and exciting and quick-moving, I think we can win something. This country is the fourth largest exporter, I think, in the world of innovative engineering. And we've got a big engineering challenge here.
No, I said I wouldn't say anything, but actually I will to that question. So, I think we have people from industry in the audience today. The project has industrial partners, but I think most people in the room also know that we have an engineered ecosystem of businesses and NHS and academics in Greater Manchester around the mobile aspects of this. And one of the specific aims there is to give businesses the opportunity to engage with researchers and the NHS to develop new business opportunities. So I think this is one of the things that is uppermost in our minds. Okay. Tony.
Thanks. I guess this might be addressed at Georgina. So the business of education. So we have clinical education in several different forms: dentistry, medicine, pharmacy, nursing, etc., etc. And you talked about MRes potentially being a way forward for bringing the next generation into this kind of space. I know that curricula are really crowded, and the GMC tell us what to do with medical education and so forth, but I'm just a bit worried that the next generation across the board isn't going to be educated in this kind of area to the degree that would be optimal. And just one, I know iPads are not necessarily related to this field as such, but anecdotally, because we have a 10,000 square mile campus, we gave our students iPads. And what they have done with the iPads has surprised the socks off us. So clearly they think differently to the kind of people in this room who are of a certain age. How can we release all of that energy with the kind of skill sets that you guys have got?
Thank you. I had heard about your iPad initiative and how well it had worked. I think there's just using some of the traditional methods of releasing people's excitement about the area in doing sort of sandpit workshops and looking at sort of health-related problems and getting people focused on those and getting them in the same room. I think there are opportunities for research symposia, attracting the right type of audience. But also you talk about using iPad technology. Iain mentioned the eLab platform about bringing these people together. That's one way that we can use the iPad for people to be able to perhaps access each other's expertise and use of methodologies. So I think it's a traditional versus sort of a different approach to getting people on board.
Anyone else want to dip in on that?
I can talk from experience as I do a lot of work at the Royal College of GPs as well. I'm the National Chair for GP Trainees. I do a lot of work for the curriculum development. And so there's actually a theme within our curriculum on primary care IM&T. So, you may or may not be aware that GP training is going to be extended by an extra year in the coming years. So part of the answer may be linking in with areas that are already existing and also into initiatives that are looking at expanding as well.
It's an extremely important question, and I'll go, we've talked about information a lot, and everybody's talking about information, and I'll just mention what Einstein said, and he was rather clever. Information is not knowledge. The mother of all knowledge is experience. What I find the most exciting about this whole program of work is harnessing incredible experience that exists in the community through the social network of scientists, really making some of them much bigger than all individual parts. Can we predict the outcomes of this? I truly and honestly believe that we cannot, because the moment you open the gateway, the moment you give people an opportunity, the moment you create a social network of scientists where each individual experience and idea is actually heard by the community and acted upon, I think that potential for incredible outputs is huge. I'm really, really excited about the potential of it. And I do not think we can put a framework to regulate for that. I think we have to wait and see.
So I'm looking at the clock and guessing that other people might be thinking it was a good time to stop. So any burning last question or comment, or shall we call that a day? No. Okay, so thanks to all the panelists and to all of you. Thanks.